Okay, hello everyone. This is Vishnu from Bharat Institute of Engineering and Technology. Here, this is my final year project, Social Media Analysis to Support Crisis Management. This is our team batch number, and we are supervised by Dr. Anita Bai Madam, and this is our team members, and our team leader is B. Amit Reddy, and next B. Vishnuvardhan and Rakesh and Sai Krishna. Next, we have done the project as a workload distribution among ourselves. Our team is of 4 members. According to this, Amit Reddy had implemented his idea and approach and code implementation. Myself, Vishnuvardhan, requirement gathering and execution. Rakesh had planned and fixing modules. Sai Krishna, PPT implementation. This is our project timeline. According to our major project of 4th semester, we have given a timeline according to 4 seminars we have done successfully completed. And now this is our reference paper, Active Online Learning for Social Media Analysis to Support Crisis Management. And crisis management. This is a IEEE transaction journal paper. It is published in 19 March 2019. Impact factor is 3.857. Its index is SCI paper. This is an IEEE transaction on knowledge and data engineering in 2019. Okay. Now introduction. As we are aware of so many crises and so many issues facing, it may be natural or unnatural, like floods, cyclones, or maybe the crisis like a bus strike and everything. Here in social media, what happening means the people are giving a fake news. In order to avoid those crises, we implemented this platform to rescue those things and do not panic others for the particular situation. In recent years, number of research studies have investigated that most efficient crises are like Norway attacks, Minopol bridge collapses, and bus strikes. Here, the social media people forces rethinking and public in crisis management regarding the new available technologies and resulting opportunities. This is introduction. Now we are going to the literature review. In literature review, we are officially base paper is on the data mining social media to discuss, and here we are using a prototype called LVQ, that is learning vector quantization, active learning with budget planning and social media analysis. A prototype is a vector space model for text data, and it's a vector representation through mapping. Literature review again. Data points are classified by prototypes considering similarity. Compared to algorithm proposed, there is a difference in adapting the learning rate and prototypes. Recent such studies, social media analysis frameworks, mostly in the context of crisis management. There are several frameworks. And here the research methodology. In the social media account of these sports, indirectly affecting to the public sector or government. In public sector, we may think the people will panic to do those things to daily routines, and government will also suffer a lot based on the income and budget and everything. In order to avoid this, we are using an algorithm called AOMPC. We propose a novel active online multiple prototype classifier called AOMPC. And here are the process steps. In order to explain this picture, I want to share few points here. It identifies relevant data related to a crisis. AOMPC is an online learning algorithm that operates on data streams and which is equipped with active learning mechanisms to actively query the label of ambiguous unlabeled data. The number of queries is controlled by fixed budget strategy. Here the proposed system we discussed, it is a learning vector organization initially like approach based on multiple prototype classification. The classifier operates online to deal with the evolving stream of data. The algorithm named AOMPC uses labeled and unlabeled data. Here is the advantage, which are tagged through the active online learning. An original online learning algorithm, AOMPC, is proposed to handle data streams, and it is an efficient way. It is a multiple prototype. AOMPC we will discuss some few advantages. AOMPC has different synthetic data sets or data generated microblocks. The data sets have different characteristics. A sensitive data analysis based on different AOMPC parameters and data is carried out. Okay, now I'm classifying how to use this thing. Okay, in order to accomplish the project, initially first now I'm going to classify the tweets upload or post in the crisis management with real-time events. The real-time events, maybe we can see here, this is our login page. Here we can see so many things like bus strike, elections, and so on. And recently we have the COVID-19 crisis also. Now according to the use case diagram, there will be user, admin, and police as well. Okay, now here the classifier preprocess relevant data, and okay, then here we are using a Google geolocation. Here you can see the pre-processing and dynamic geolocation. Here pre-processing, when we are using this social media items, here we are using a geolocation. We are using geolocation API to detect the current location of the user who are registered in this system, and the API may be a Twitter, FB, or Insta account, and especially it is possible only when the message includes hashtag, and all these are real time. This is the use case diagram as we know, and this is project application AOMPC we are using, and the results logging page. For regarding to this logging page, we are going through, and this is a code service forms.ply. We will get this output, and we should copy this through a link, and we will get an home page like this. So through the PPT we are going, this is the format, this is the user page, this is the login page, and this is the admin page, this is the police page. And my conclusion is, as we are not panicking about the situation, and we are using the AOMP server to find the crisis, and we are ready to obtain this project to be successful, and we are going to implement in this project in a reality way to find out the solution, and we will avoid the fake news through social media, and with the help of the government we are going to be successful in finally.